Triangle geometry then, often shortened to trigonometry. And there's a key feature of trigonometry that we often forget, but is actually really fundamental to how the triangle works. If we take the longest side of the triangle, it will always be opposite to the largest angle. And that relationship between side and angle opposite pair extends through the other two as well. Hence, the shortest side will be opposite the smallest angle, and the mid-length side will be opposite the mid-sized angle. This relationship is really helpful to us when we get an answer to a trigonometry problem, because we can immediately check whether the answer is plausible or not. If our triangle has a 90-degree angle, it's a right angle triangle, it has to be opposite the longest side, which is called the hypotenuse. That's because you clearly can't have more than two or more than one 90-degree angle in a triangle. If we have a marked angle theta in our right angle, we often refer to the side opposite that angle as the opposite side and the side next to it as the adjacent side. That then leads us to our basic trigonometry ratios of sine, cos and tan, often remembered as SOHCAHTOA. But don't forget, there is actually a relationship purely between the sides, which is Pythagoras, which tells us that the two sides next to the right angle squared and then added together will be the same as the hypotenuse squared. If we go back to our side angle opposite pairs for any triangle, when we come to labelling up these sides, we often use the same letters for the side and the angle opposite pairs, but we use capital letters for the angles and little letters, the corresponding little letter, for the sides. That then leads us on to other relationships. So the sine rule is a relationship between these side angle opposite pairs. So the ratio of the side and the sine of the angle will be the same for all three side angle opposite pairs. You'll never use it in this three-part form. It's just put here to emphasize it works for all three pairs. It's also worth remembering that it's always the sine of the angle, never the sine of the side. The side appears on its own, the sine of the angle. The angle never appears just by itself. You can have this as a ratio, the other way up. A little tip when you're using these is to always use the version that has the unknown quantity on the top. So if you're trying to find an angle, you would go with the second version because it has the angles on the top, whereas if you're trying to find a side, you're better off using this version. Cosine rule, using the same triangle, it starts off very like Pythagoras, a squared equals b squared plus c squared, and actually if you make angle A 90 degrees, you'll find cos of 90 degrees is actually 0. So this whole term here is 0 in that circumstance. So you would get Pythagoras' theorem. In fact, Pythagoras' theorem is really just a special case of the cosine rule. It's worth noting that the right-hand side here is made up of a side, an angle, and the next side. So it's two sides and the angle between them. If you have that side angle side structure, or SAS, that suggests that the cosine rule is for you. The last one, the last relationship that we look at is the area of a triangle, and this tells us that if we take any two sides and the sine of the angle between them, so in this one A, B, and the angle between them is C, then we can find the area of the triangle by doing a half AB sine C.